All right, let's go through this. So this first one, we're just asked to simplify. So what can we do here on our square roots? Yeah. These are negatives under the radical, so we know there's going to be i's involved somewhere. So this first one, we could rewrite this as the square root of -1 times 36, because we know that the square root of -1 is a thing. And then we can look at the square root of 36, because our square root of -1, that's the piece we call I. What is the square root of 36? 6. Very similar vibe for the 81. I can do our -1 times 81 just to get that -1 away. I can weigh that up. There we go. Square root of 81. So our square root of -1, that's again called I. What is square root of 81? 9. So I have I times 6 times I times 9. What do we have there? Super close. So my 6 times 9 is, in fact, I. 54. And then my i's, I have I times I, so it's actually I squared. But I squared actually means what? -1. So this has a final answer of -54. Because that comes from that I is the square root of -1. I squared is the square root of -1 squared. Square root and the square cancel out, so we just have -1. Okay, so that's our final answer on that one, is -54. How about on the right-hand one? What are we going to do? I was like, I heard an idea, but I can't tell what it was. You can absolutely box it, or you could distribute it. Either way is fine. I'll do a box. When we box multiply, we put our factors on the outside. So my 3 plus 2i goes on one side, and my 7 minus 4i goes on the other side. Multiplying them in, 7 times 3 gives me 21. 7 times 2i gives me 14i. 3 times -4i is -12i. And -4i times 2i gives me -8i squared. So I'm going to pull everything out and line them up so we can start combining things together. I'm just going to pull the pieces out. So we've got our 21 plus 14i plus -12i, so it's the same thing as -12i, plus -8i squared, which is the same thing as -8i squared. It happens. Slow down, be careful. Because now we can combine some like terms together. I've got a 14i minus 12i. We can simplify that down to 2i. But we also have this I squared to deal with, which we talked about on the last one. That actually equals -1. So this is -8 times -1, which means what we're going to have down here is our 21 plus 2i plus 8. So our final answer is going to be what? Gorge. Okay. Questions on these ones? like that we're checking in on each other. I like that we're checking in on each other. Good buddies. Okay, so it's up to you guys. If you want to work by yourselves, that's totally fine today. If you want me to do any of the problems from the review with you, we can do that. I have the whole thing right here. I'm happy to work any of them with you if you want. But if you just want this time to work, that's okay too. So if you have one you want me to do, just give me a number. Four A. Okay, yeah, we can do the first one on 4. Boop. This one. There is a common factor of 5. 5 is actually not the greatest common factor. What else do they have in common? X. Why is this pen look so gigantic? Oh my gosh. I'm going to write that a little bit smaller. So we can actually take out 5 and X on this one. What's that going to leave us with when I take out 5 and X? Is there an X left over here if I take an X out?
Oh, no.
Is there anything else I can do on this one to factor it? So that's my factored form right there. 5x times x plus 2 equals 0. How do I find my solutions?
Put 5x equals 0 and then x plus 2 equals 0?
Absolute perfection. Ooh, let me get a different color on that one. If it has an x in it, we set it equal to 0. So on my red one, 5x equals 0. What does x equal? 0. So that's one of my solutions. On my green one, what do I do to get my x by itself? Correct. Subtract 2 from both sides. So we get x equals negative 2. Okay, yeah. Any remaining questions on 4A before I move on to number 5? Cool. Number 5 states we are supposed to use our square root property. If it says we're using our square root property, what that means is this left-hand side should be a perfect square trinomial, or whichever side has your x squares. What's up?
How'd you pull that out?
The 5x?
You just,
What's up? I need more nouns, please.
oh, never mind. I got it.
Okay. Great, because I'm still not entirely sure what you're looking at.
I was just looking at our last problem.
Okay. I kind of figured you were looking at, but I had none nouns to go off of. I need to buy a noun. All right, so if it tells you to use the square root property, that means there's something in here that's a perfect square. It's either an x squared equals a number, where I could just square root both sides, or we have a perfect square trinomial. If we tell you to use the square root property, we're setting it up for it. So this should be a perfect square trinomial, meaning it follows that pattern. So you'll have to follow my brain on this one, because otherwise you're stuck at the whole page, where we have something that's been perfectly squared over here, something that's been perfectly squared over here, and the middle should be made of 2 times the front times the back. We usually use question mark for this. If we need to figure it out, we don't actually necessarily need to figure it out because it should be built like that anyway, but it's a good idea for us to check. So what does question mark, bless you, need to be for this piece? 12. So our question mark is going to be 12, which means what should our C be for this to be a perfect square?
1/4.
Which it is, which means this, in fact, is our perfect square right here. And so what we're going to do is write it in its perfect square form, where it's the thing that was squared in front. Our question mark goes in the back. And the sign we use is always this first sign in our expression here. So that's our perfect square form. And it is currently set equal to 81. So if it tells us to use our perfect square property, it should be able to set up like this, very, very less labor intensive than you think. So you don't have to complete the square. It should already be complete. So then we could absolutely square root both sides. That's going to give me what? Equals plus or minus 9. Because when I square root both sides of an equation, I have to include my plus or minus. As I have more than one option, negative 9 when squared still gives me 81. So since I have two options and everything is tidy whole numbers, we need to split it. We're going to have our x minus 12 that could equal positive 9. Or we could have our x minus 12 that equals negative 9. I don't know why that 9's so blocky. There we go. So on this blue one up here, what do we get? X equals? On my purple one, x equals? 21 and 3. Both of those are solutions. So if we tell you to use the square root property, it should be set up for it. Otherwise, we'll just tell you to solve however you wish. And you can use the square root property, but you don't have to. So if you're told to use the square root property, we are trying to give you a clue.
See, after this I get stuck. When it equals to 0, I just get it equal to 0, and then I'm just like,
Which one are you looking at, Alex?
I'm at 6 now.
Number 6. Which? You don't gotta do nothing after on 6. Just find C. C equals what? And stop.
Yeah, but like I couldn't. Oh, E equals 5 squared or something like that.
Are you on a homework?
No.
Okay.
Am I allowed to turn this into something?
If you're done with it, yeah. Which one are you looking at, Alex? Uh-huh. So this is trying to make it fit this pattern here. So it's this same kind of property. Okay. So our question mark is what?
Why is there a pen connected?
Because people forget to put their name on it, then they steal the pens off of my desk, and then I just lose my stuff. So it's just there because then people don't see my stuff. So our question mark is going to be 5. You're exactly right. So our C would need to be 5 squared. What is 5 squared? Wait. Okay, I lost you there. Hang on. Let me go back and start from the beginning because I lost you. I heard it. So we want this to make our perfect square pattern. So we know the front is going to be something that's been squared. And we've got our x. The C needs to be made of something that's been squared. That's part of the pattern that we're using. And the middle piece has to be made up of 2 times the front piece, that x, times that question mark from the back. So what does question mark have to be? Question mark has to be 5. Because this 10x needs to equal this whole chunk right here. So if question mark is 5, what is this chunk?
5.
This guy's 5.
Squared.
5 squared. C needs to be 5 squared. What's 5 squared? 25. So my C equals 25. So this polynomial, or the trinomial, I could write it as x squared minus 10x plus 25. And if we wrote it like that, I could write this in its perfect factored form like we did over here on this one, where I take my what's in the front and my question mark and put it as its factored form. This is a plus. So writing it in its perfect square form is when I have my thing that was in the front, my question mark, which was 5. It uses that same operation, and then it gets squared. And then you stop. All we need is to find C, which is the 25, and to put it in its perfect square form, because that's what these are.
So the actual answer would be 8 plus 5.
So for finding the value of C, it'd be that, C equals 25. Our perfect square trinomial would be that.
I wrote that.
Stop. You're done. Don't try and keep going.
Okay, that's why I had it set up like that, but I just,
Mhm.
what am I doing? Like, I had everything right, I had everything on my paper. I just didn't know what I was looking for.
Yep.
I guess I just didn't read the question.
It's okay. I was say, but don't try and keep going. I had a lot of people that did that on that homework that tried to solve from there. I'm like, it doesn't actually equal anything, so don't keep going. Any others that you guys want to work through?
So that's 6.
6. Oh, is it move back in?
Yeah.
Yeah.
Can we go back to 5?
There you go. You can see both.
4.
Oh, 4. I have to go out a little bit farther.
I wanted to do another one at 4.
Okay, we can look at another one at 4. I'm just trying to get it because we wanted to see. I'm going to leave it down here on 6 for just a second so we can get it written down. I do also have the answer key for this posted. All right. Which one did you want to look at, Alex?
Let's do the 6th one.
You could hurt.
Third? Yeah, do the third one.
Do the third one? We can do the third one.
The third one was easy.
It's a very similar vibe.
It's a 1.
So let's take a peek-see at it. We're told to factor and then solve. So when we factor things, how do we start? What should my first step be? Yeah. Try the X thing. That's part of our factoring.
A is C.
Yep, so we want our A times C at the top. So what do we get at the top? -6. My 3 times my -2. B goes on the bottom, which is +1. We need a pair of numbers that will multiply to make -6 and add to make a +1.
So it's -3 and 2.
Yeah, as I say, we're going to need 2 and 3. We know that those definitely have a difference of 1. And if one of those is negative, it'll multiply to make a -6.
-2.
The 2 needs to be negative because I need it to be able to add up to that +1. So finding those two values is probably your trickiest part. And then the next trickiest part is filling in the box properly, because this is the one where people get thrown off. A times C. So my A is 3. My C is that -2. So 3 times -2. That's where we get that -6 from. So the pieces that go into the box, I start with the whole A term, my 3x squared. And that'll be the thing people forget the most, is that 3 there. And then the bottom right box gets that -2. The two side boxes get these 2 pieces we get out of the x frame. These are to figure out how this guy gets split into 2 boxes. That's all they're for. Correct. So we need to pull our factors in columns and rows. What is the greatest common factor between 3x squared and 3x?
3x.
3x. What is the greatest common factor between negative 2x and negative 2? Mm-hmm. What is the greatest common factor between 3x squared and minus 2x?
X.
Just an x. And between 3x and minus 2?
1.
1. We will never, ever, ever have a factor of 0 from a box. Ever. Never, ever, ever. Everything can be multiplied by 1. So if you don't see anything else, it's a 1. So these are our factors. So our factored form, we've got our 3x minus 2 as one of the factors, and our x plus 1 as the other factor. What do I do to find my solutions?
3x minus 2 equals 0.
Gorgeous. 3x minus 2 equals 0,
And x plus 1 equals 0.
and x plus 1 equals 0. Every factor, any chunk that has an x in it gets set equal to 0 to find its solution. So let's do the blue one first because it's going to be a little bit easier. X plus 1 equals 0. How do I get my x by itself? Minus 1. Say that again. What was that? X equals negative 1. I thought you said square root of negative 1 for a second there, and I'm like, where are you getting square roots? All right, so one of my solutions is negative 1. On the red one, what do I need to do?
Add 2.
Plus 2.
Plus 2. So I get 3x equals 2. So what does x equal? 2 over 3, which is icky, but fine. So my other solution is 2/3. I recommend it because our test is tomorrow.
Tomorrow. I know.
I say, to be fair, not allowed to be surprised by it. What's up?
So we would just do the same thing for the second one?
Mm-hmm. Yep, it's factorable. So the middle one should be factorable as well. Set it up the same way. It's like you guys were right. The third one is the hardest one, so I'm leaving you the middle one to do.
And the first one we just did it because we found the greatest common factor.
Because we had that greatest common factor, which is why we did not need the x or the box.
Then where'd you get the C from? How'd you get the
There was no c on this one. This one, we just have an a, x squared, and a bx. There's no c. If there is no c, there is a greatest common factor of x. Guaranteed. So if there is no c value, you're going to be able to pull an x out.
And then to get the 2, how'd you get the 2 in the greatest common factor, right?
So we took our 5x
Yeah.
that was greatest between the both of them, and I divided it out of each one. 5x squared divided by 5x leaves me with x. 10x divided by 5x leaves me with 2.
How do we know whether to use that box in the equation?
If I have a c value, I can't do it this way. This one had a c value. We had a, b, and c. So you can always try and factor if we have an a, b, and c. It's not always going to work, but you can absolutely try it because it's something we're more comfortable with usually. Good questions, guys. Good questions. Any other that we're sticking on?
Can you do
Number
number 7?
7.
What's the greatest common factor of 3 and 21?
3 times 1.
No.
I-
He said what's the greatest common factor of 3 and 21?
Oh, 3 and 21. Okay, 3 and 21, yes. I heard 3 and 1, and I heard you say 3, and I'm like, pause. All right, so number 7 has a whole lot of story in it. We've got a projectile, it's launched, we got a whole lot of stuff, blah, blah, blah. We're given an equation. We are asked to find, first thing, find the vertex. How can I find the vertex on a graph or on a equation? It's actually how we started this chapter. Look at your list of formulas and see if one of those might help us figure out where we can find our vertex.
I don't know. Nice teacher.
Boop. So look at our list of formulas over here.
X squared.
So this is our vertex form. Unfortunately, this guy's not in vertex form. If it was easy peasy, lemon squeezy, we'd be ready to rock and roll. So we want to be able to find our vertex.
It's in that, I think it's that first one.
It's in this first one. It's in our standard form. So I want to take it from this, basically, over to this. So is there something over here we could use that'll help us do that?
Oh, AOS.
Our axis of symmetry. This gives us the x value of our vertex. It's going to give us our h. So we're going to use our axis of symmetry to be able to find the vertex of our graph. So our axis of symmetry, that uses our x equals the opposite of b over 2a. So that's the piece of the formula. So we need to look at our equation here and fill in the pieces. What is our b value? 192. So our x equals the opposite of 192 over 2 times our a. What's our a? Negative 32. So we're going to simplify this. So I've got 192 over 2 times negative 32. So that's 190, or sorry, the opposite of, my handwriting has turned to trash as soon as I picked it up and leaned back. The opposite of 192 over 2 times negative 32 is negative 64. So what is negative 192 divided by negative 64? When in doubt, type it in the calculator. Let me get my calculator open.
What? Oh, it equals negative 3.
Negative, careful.
It is. It's not.
Oh, it's positive.
Thank you. I've got a negative over here out in front. And a negative down the bottom. The negatives cancel out. We have a positive 3. So we wrote this with an x because that's what our formula was. But this doesn't actually have any x's in it. So what letter is this really? T. So this is not a t, an x. This is our t. So 3 what's in the context? T stands for what?
Seconds.
Seconds. So 3 seconds is where something important happens. 3 seconds is where we're at our vertex, where we're at our highest place. What is the height we're going to be at 3? How do I find that out? Substitute it back in. So our height equals negative, I got to zoom it in, negative 32 times our t of 3. Oh, I got to see my equation. Squared. Plus 192 times our 3 plus 9. So we're going to type this in the calculator and be very, very careful about it. What do we get as our height? What does this simplify down to be? Yep. 297. So our vertex is at the point 3, comma, 297. So the height that our projectile is at 3 seconds is what? 297. So in context, it gets to 297 feet 3 seconds after launch. So just watch your units and be careful on that. We don't have to write it in vertex form. We're just finding our vertex. Okay? So be careful with that. Make sure we practice some of these things. We've got about 7 minutes until the announcements. If you want to pick one more, we can. If you want to have the next 7 minutes to work, that's fine too. Number 8. Using our quadratic formula. That's an excellent idea.
Quadratic formula is the next one, and it shows us.
Correct. On our formula sheet, yes. The last one is our quadratic formula. What is an important thing we need to remember before I can do anything with my quadratic formula? Looking at this equation, what do we need to do first? Subtract 8. We have to get the dang thing to equal 0 first. So I'm just writing my quadratic formula over here just so I have it on the same page. On the test, it will be at the top of every single page, so you won't have to flip back and forth. I just wanted us to have more room on the review, so I didn't put it at the top of every page. But on the test, it'll be at the top of every single page. So our first step we need to do is to get this thing equal to 0. We have to. Super duper important. So we have our x squared plus 12x minus 8 equals 0. So what is my A? 1. What is my B?
12.
What is my C?
Negative
8.
eight.
Those pieces are important. When we do our quadratic formula, we start by doing our discriminant. That guy, the bit under the radical, we start with that piece first. It does help, I promise, to do that piece first instead of doing it in one big chunk. Because we should have our 12, our B squared minus 4 times our A, which is 1, times our C, which is negative 8. So our 12 squared, that gives us 144. Minus 4 times 1 times negative 8, we get plus 32. So the value of my discriminant is going to be what? 176. So what kind of roots are we going to have? 2 real roots. Are they going to be nice and pretty, or are they going to be super icky gross decimally? Super icky gross decimally, because 176 is not a perfect square. So when we get decimally answers, we know we're right. So then we're going to finish out our quadratic formula, plugging all the pieces in. So our x equals the opposite of b, so the opposite of our 12, plus or minus the square root of our 176 over 2 times our a, which is 1. Well, 2 times 1, that's just 2, so we don't necessarily have to have that there. And then what we need to do is try and simplify it, which you can try and do by hand, but why? So what we're going to do is we're going to use the calculator to simplify it. So we're going to use our fraction. We're going to have our negative 12 plus the square root of 176 over 2. And you can just type the whole thing in like this. Boop. That will simplify it for us. It simplifies the radical and it simplifies the fraction all in one go. So there is one of my simplified radical solutions. Is 2 square root of 11 minus 6. So 2 square root of 11 minus 6. We are also asked to get our decimals to 3 places.
Well, you simplified it to that? You simplified it? To
I
that?
typed it into the calculator.
Man, that's bogus, man. I didn't type it into the calculator and put that on there. I just put the. Never mind.
Simplified. We need it simplified.
It's simplified right there. You know, reason is.
And we need decimals anyway, so we have to use the calculator anyway. So might as well let the calculator do it
I
right.
got the decimals right. Because I got exactly that right now.
Good. So
That
take.
would be the other answer.
So this would be our decimal answer. So 6.33 or 0.633.
How'd you get 32 from?
Which part?
What? I saw 144 goes to 36. 32.
Over here.
Yeah, no,
Oh, it was 4 times 1 times 8.
okay.
So we need our other simplified answers. So if I look at my calculator, I did the plus when oh, come on.
30.
I did plus right here. I want to do the minus one. I don't want to have to type the whole dang thing in again, so I go back up to it, hit enter, and it puts it back in the active line. And all I got to do is switch that to a minus. And then it does the same thing. Negative 2 square root of 11 minus 6. So it's really close. It's very similar. And to get our decimals, we hit the little 2 arrows above the enter key down here. That's going to give us our decimals. So negative 12.633.
You have big hands and you have the littlest phone. Like, how am I calling?
So we do need to have our simplified radicals, that's these guys, and our decimals. You do need to have both. Okay? Answer keys posted. If you have more questions on stuff, please let me know. I'm more than happy to help you through it. But announcement bell is just about to ring.
That's what she